Oh, wait.
Worked. I mean, not worked, but I see the loading
Hi.
thing. Yeah, stream will begin shortly.
Okay, cool.
Hello?
Bet.
Hi, Vinaj. So, oh wait, is it working?
All right. Welcome, everybody. This is the Intro to TinkerCAD workshop. My name is Alan Liao. I'm one of the tech directors for IEEE UTD. And yeah, thank you for coming out. I know this is a Friday. Even though this is a Friday afternoon, you guys are taking the time out of your day to join this workshop. So really excited for this. So we're going to go ahead and get started. So for everyone who's tuning in at the live stream, could you please sign in with this QR code? It's a very short, simple, first, last name, net ID, and what kind of workshops you would like to see in the future. So I'll give about 5 minutes or so for everyone to do that.
Also, if you're done signing in, try and create a TinkerCAD account. So just go to tinkercad.com and then create an account with your email, just so we can get set up. Thanks, guys.
Yeah, well, if you guys are confused on how to set up a TinkerCAD account later on, we do have a slide that has instructions to do everything. So no worries if you can't get that working right now. Hello. For those of you who are just now joining in, we're about to get started. Okay, if you guys could sign in with this QR code, that'd be awesome. And I guess we could do a little quick, questionnaire thing in the YouTube live stream chat. So if whoever, for anyone whose first IEEE Tech workshop is this workshop, let us know in the chat. Nice. Got a few first timers. Awesome, awesome. Glad y'all are with us. This is going to be really exciting. So if you guys this is going to be the start of a workshop series that we're going to be doing throughout this semester. So this workshop series is going to be split up into multiple workshops. This will be the beginner-friendly sort of the intro to TinkerCAD, which is TinkerCAD is going to be the main software that we're going to be using, main tool that we're going to be using for these workshops. And so each workshop is going to be building off of the previous one. So it's joining this workshop will give you a really good sense and foundation for the future workshops that we're going to be having later on in the semester. All right, well, I think this is enough time for everyone who still hasn't signed in, make sure to sign in with the QR code. Very short sign in so we can keep track of everyone who's joining us today. But with that, we're going to go ahead and get started. So today we're going to be learning about TinkerCAD. So TinkerCAD is an online simulation tool for 3D modeling, circuit design, and coding. So this is a really cool tool, especially right now during COVID, when we can't go to school, can't work together with physical components, physical things, right? And so everything is online with TinkerCAD. And so TinkerCAD is it's a software that's developed by Autodesk. So if you guys haven't heard of Autodesk yet, it's a huge company that develops things like AutoCAD, a lot of engineering tools and software that are very widely used in the engineering field right now. So TinkerCAD is an especially user-friendly and student-friendly tool in that it offers a lot of free lesson plans. So if you want to learn anything from Arduino to coding to 3D modeling, they have completely free lesson plans that you can go through, learn all of that if you're interested. And so for the purposes of our workshop today, we're going to be using the circuit design aspect of TinkerCAD. And so the circuit design aspect allows us to use a bunch of components, including Arduino Uno to be specific, sensors like ultrasonics, tilt sensors, gyroscopes, motors, DC motors, servos, and also logic gates, and a lot more than that. So it's really useful, very versatile, and you can code everything and simulate everything all in one place. So you can create a complete project on TinkerCAD without needing to buy the supplies, you know, go out and go to like, I don't know, like if you're working at the makerspace at UTD, you won't have, you know, potential exposure to COVID, because that's definitely something that, you know, it's a pretty high priority to make sure everyone's safe these days. So yeah, so this is a really good tool, completely free, versatile, and very convenient. So going on, so for those of you who have never worked with Arduinos before, this is an Arduino is a very useful tool. So an Arduino is a microcontroller. So essentially, it's like a mini computer, and you can essentially customize it, build a ton of like circuits, projects, anything that you want using this tool, and it essentially, right, it acts like a computer. So the benefits, the strengths of Arduinos are that it's versatile. Again, you can use it for any kind of home projects, personal projects, anything like that. Power, very low power usage. You can run it just from connecting it to your laptop or computer via a USB. And it's also low price. It's pretty cheap. Definitely not as expensive as a regular computer, desktop computer that could cost like, you know, hundreds of dollars. So Arduinos are usually used by anyone from like hobbyists to professional workers who design products for like smart devices, smart homes, things of those kinds. And so just like a brief sort of anatomy of the Arduinos. So as you can see here, we have the USB port, which is where you'll be connecting the power to the Arduino. And you can connect the USB to, you know, your laptop, your computer, anything like that. And here you can connect a 9-volt battery if you have an adapter, in the case that you do need more voltage. So sometimes you need more voltage for different projects, and the Arduino lets you have that capability. So these pins right here, so the Arduino has a lot of pins. These are essentially the main outputs of the Arduino that you're going to be working with. So you'll see here that you have a 5-volt output pin that has it essentially provides a constant power of 5 volts to the circuit. And then you have 2 ground pins, and these are just multi-use. I mean, it's just for grounding a circuit. And then you have over here, you have 6 analog pins. These are the output pins that measure a continuum. And so usually this is some sort of sensor readings that have, you know, that could be any kind of real number, and it's not really a discrete number like integers or something like that. And then up here you have 14 digital input or output pins, and these are essentially you can also use them for regular sensors as like these ultrasonic sensors with real numbers as outputs, or you can use them as like, you know, discrete values such as like on or off, or power, or on power, off power, everything like that. So yeah, so this is just a very basic Arduino anatomy, and very, very convenient, very versatile. So moving on to breadboards. So for any of y'all who have never worked with breadboards, Breadboard is a very, very useful tool again. And so if you guys have never wondered what a breadboard, or why a breadboard is called a breadboard, it's actually very interesting. So the original breadboard was actually, so back in the old days, people would take their mom's breadboard from their kitchen and actually build a circuit using that breadboard. And they would either use like sort of like putty or like nails to nail nail their wires into the breadboard, and that's how they would use, that's the platform that they would use to build circuits. And it's really cool. It's multi-purpose. You can use it to make dough, or you can use it to create electronic circuits. Convenient. You can totally, it's in every single household. You can straight up get it from your mom's kitchen, right? And then it's also aesthetic. Like, look at those nice like wooden curves. Like, normal breadboard these days wouldn't have those kind of curves, right? But yeah, so unfortunately modern breadboards aren't like that. They're now single purpose. They only serve the purpose of creating electrical circuits. They're inconvenient in the aspect that you're not going to have, like, every household isn't going to have this. You're going to have to buy a breadboard if you want to use one. And it's definitely not as aesthetic. It's just, you know, really plain and simple. So, but yeah, all jokes aside, breadboards are very, very useful in that it allows you to create a circuit without soldering. So breadboards are mostly used for prototyping, and you can create circuits without needing to, you know, solder, which is essentially like a permanent thing, right? So whenever you connect things into a breadboard, you just connect them, and then you can take them out, mess around with it, change things up if you made a mistake, and it's super easy to use. So breadboards are, so the basic anatomy of the breadboard is you have these power buses running along each long end of the breadboard. So these power buses are essentially strips that are connecting the holes all the way across. And typically you have the, it's going to be labeled negative or positive. So the positive side is the line of holes that is closer to the positive side. That's typically what you want to connect your 5 volts or your power supply to. And the cool thing is all of these holes along this horizontal line are connected with each other. So once you connect one side, all of the holes for the along the rest of that line are also powered. And then on the negative side, same thing. If you connect one side to ground, which is typically what you're going to be using this for, it grounds all of the holes that are adjacent or along that line as well. And the same thing on the other side. So you have 2 power buses. And also the terminal strips for the breadboards. So the terminal strips are these, or the rest of the holes that you see on the breadboard. And these terminal strips are usually labeled by number and letter. So the numbers are typically labeled on right next to the power buses, power bus like lines, and the letters are labeled on the sides, on the very ends, the far ends of the breadboard. And so these terminal strips are connected. The holes are connected in this orientation. So the orientation is actually perpendicular to the orientation that the power bus connectors are. So instead of connecting all the way across long ways, it's connecting typically five holes at a time together. And so they'll all be connected. If you add power to one of these, then the other 4 holes will be powered. And then keep in mind that there's a divot in the middle, so it separates these each half of the breadboard. So these are not connected to each other if you go across. Now this divot actually has a purpose. So the divot is it provides dual inline support. So dual inline package support. Sorry. That's what DIP stands for. So essentially, if you have any sort of integrated circuits, so integrated circuits, any kind of microchips that you're going to be placing on the breadboard, the little divot here is actually to help save space, and it's actually designed in a way that it perfectly fits those integrated circuits, and so that you can maximize your usage of the space on the breadboard. And then finally, the binding posts. These are if you ever need to connect your breadboard to an external power source like a battery pack or a straight up wall socket adapter, then you can connect your positive and negative to that side, and you can use those to power your breadboard as well. So all breadboards will have at least these first three: the power buses, terminal strips, DIP support. They'll typically have those three. Binding posts, not all breadboards will have those, but they are useful as well. Yeah. So if any of you guys have any questions, you guys are confused about a certain part, put it in the chat. Mira and Sarvan are our two moderators. Sarvan is the other technical director working with me, and then Mira is vice president for IEEE. So we're all here to help answer your questions. So please, if you have anything on your mind, you can put in the chat, and we'll try our best to answer it. Okay. So we can go ahead and move on. So if you guys have not yet created a TinkerCAD account, so today, I mean, by the name of our workshop today, it's an intro to TinkerCAD account. So TinkerCAD, to create a TinkerCAD account, you will go to tinkercad.com. You will click on the Join Now button on the top right corner, and it'll ask you to create an account using either your personal Gmail, I think Microsoft email, or I don't remember what other platforms they allow you to use. But essentially, you can create an account, sign in with whatever account you want. Doesn't have to be your UTD email. And then once you've created your account and signed in, if you go to the left column, you'll be able to see, well, you can go ahead and explore everything, but if you go to the left column, you'll see something like 3D models, circuits, and code blocks. If you can click on circuits, we're going to be working on circuits today. So you can go ahead and create a new circuit and play around with that. All right. Once you guys have created your TinkerCAD accounts and have created a new circuit, we can go ahead and talk about LCDs. Yeah, we can. Let's wait until actually everyone's created their TinkerCAD account, so we're all caught up. Because right after this, we're going to be diving straight into a TinkerCAD project, and really cool. We're actually going to be we're going to be learning how to set up an LCD display today. So you can make an LCD display display anything that you want. And so you can put funny messages, anything really. Yeah, if you can create a circuit, that would be, um, yes, that's what we're going to be working on today. So you can go ahead and create a circuit, and we can straight up dive into it as soon as everyone's done. All right, so let's go ahead and get started on the project. So just a brief overview of how LCDs work. So the way how LCDs work is, so LCD first stands for liquid crystal display, and they work by using liquid crystals to produce an image. And these crystals are actually embedded into the display screen, and there's a backlight that's used to illuminate them. So if you've ever seen LCDs, I mean, you can really see LCDs anywhere. So your computer monitor, your TVs, most of these are LCDs. LCDs are very widely used, and today we're going to be learning how to actually program one and wire one yourself. So yeah, so the actual liquid crystal display is made of several layers, including a polarized filter and electrodes. So if any of you are curious about how an LCD works and how you can see actual words and text pop up on a display, that's the very, if you guys are interested into the technical details of it, then that's how it works. So yeah, so LCDs, liquid crystal display, and it's mainly used to show text graphics, and it can also display readings and calculations. Essentially anything that you code the LCD to show, it's essentially like a print like output. Yeah, anything that you code it for. And so going on, so today we're going to be creating a basic LCD circuit. I'm going to go ahead and go to TinkerCAD and create a new circuit with you guys. Alright, so if you guys are with me on this, you'll see this empty screen, TinkerCAD, and this empty new circuit. And so just to kind of familiarize y'all with this, so here you've got buttons that can rotate. You can delete a component, you can undo, redo. You can also annotate and view or hide different components. So whenever you're arranging them, these are very useful. And so here on the right side, you'll see if you click out, if this is already like collapsed, you can expand it, and you'll see a bunch of components that you can use. So these are the basic components. You've got your resistors, LEDs, push button, potentiometer, everything, like all of these things. These are the basic ones. If you go to all, you've got a ton more things. You've even got a potato battery and a lemon battery. So I don't know why. I mean, if you want to work with a digital potato battery, that's all you. But honestly, in my opinion, it's more interesting to hook up an actual potato and create your own physical potato battery, because that's, I mean, isn't the whole point of having a potato battery? So yeah, so you will see these breadboards, right, and then the Arduinos. So today we're going to, the components that we're going to be using are a breadboard. So you can go ahead and click and drag that onto the screen, and the breadboard will come up. And so as you can see, like I said, these are the power buses, the terminal strips and such. So these, if you highlight over them, you can, it actually highlights all of the holes, the terminal holes that are connected to that specific sort of connection. So yeah, like I said, these are perpendicular to how the power buses are connected to. But yeah, so the other components that we're going to be using is, of course, an Arduino Uno. So yeah, this is going to be our Arduino that we're going to be using. You can also use different microcontrollers. You can also use the ATtiny. I've personally never used that before. If any of you have ever used the ATtiny before, let us know in the chat. That would be really cool to see. Me personally, I've never heard of it actually, but I don't know, maybe it could be really useful, and I'll probably want to learn it later too. So the other components that we're going to be using are the LCD display, which I probably passed on the way up. Here it is. And then also a potentiometer. So this is, I should have done this earlier, but yeah, potentiometer. You can actually search for your components. So we're going to actually put the potentiometer right on the breadboard. Put it right here. So you have three, so you'll see that the potentiometer has three sort of terminals on it. It has terminal 1, has a wiper, and terminal 2. So these three, you can just connect them into 3 adjacent terminal strips, and we'll be using those later. And then last but not least, we're going to be also adding a, that's not spelled resistor. So we'll put the resistor right over here, so that one end of the resistor is connected to power, which will be connecting the power to the plus power bus here, and then the other connection will be at the bottom, just right under it in this terminal strip. And the so you can actually set the resistance of these resistors to anything that you want. So for our cases, we're going to be using a resistance of 220 ohms. So you can go ahead and click that, select it, and set it to 220 ohms. And yeah, so those are all the components that we're going to be using today. So very simple, very basic. Now all we have left is to do wires. So wires, really cool. All you have to do is select, so if you see any of these like highlighted buttons or highlighted like squares or holes, you can, if you want to connect a wire from anywhere, you just click the hole and you can drag it around. You can see where the wire is going to go. And if you want to like do some like nice wire management things. Let's say if I wanted to connect this to, wait, let's not like just do a random. Wait, let's say I just, oh man, okay. Let's say I made a mistake. I didn't want to wire this, so you can select the wire and just press delete, or you can just select the wire and then click delete up here on the top left to delete the wire. But for us, so right now I'm just gonna like set up the power buses. So this is a very simple way to do things. So I'm gonna go ahead and click 5 volts. So if you find 5 volt on the Arduino, you can go ahead and click it to start the wire. And then I like to make my wires at 90-degree angles. So I'm going to go ahead and click there and make it a 90-degree angle. Set that up. And then click here. Oh no, that's off by a little bit, I think. Alright, there we go. So there's our first wire. We've connected 5 volts to the positive power bus on the breadboard. And for me, I like to keep the colors of the power and ground consistent. So power, I usually keep it red because it's red on the breadboard. And then for ground, we're going to connect ground on the, which is right next to the 5 volt pin on the Arduino. And we're going to connect that to the negative power bus on the breadboard. And I'm going to change that color to black. So I like to use red and black for power and ground. You guys can use whatever you want. I've just found that it's easiest to be consistent with the colors. And yeah, so now that we've connected these two, essentially whenever we turn on the Arduino or start the simulation, power will be provided to every single one of these holes along this breadboard, and then ground will be, it'll ground all of these holes in this power bus. And to also use the other side, we can simply just connect the power bus to this side, and it's as simple as that. And so now both positive power buses on both sides of the breadboard are now powered with literally just 2 wires. So super convenient, super simple. I'm going to do that same thing with ground. And voila, there it is. So now we're going to go ahead and hook up the LCD. Actually, let's go ahead and start with the potentiometer first, because the potentiometer is really simple, straightforward to do. So the potentiometer, you've got terminal 1, terminal 2, and wiper, like I said before. So terminal 1 is going to be your power terminal. So you're going to connect to this. So I like to connect this last hole here to A, just so it's like it's like clean, and you can easily tell where the wire starts from. But yeah, since these are all part of the same terminal strip, they all share the same value, same power essentially. So we're going to be connecting this directly to the power bus on the breadboard. And since this is 5 volts, this 5 volts constant power, we're going to be setting this to red, just like these wires right here. And then the same thing for the terminal 2, but terminal 2 will be for ground. So we're going to be connecting terminal 2, or this terminal strip, to ground, and we're going to set that to black as well, since it is grounded.
Alan, someone asked if you can zoom in.
Zoom in?
Yeah.
Oh, yeah, of course. All right. Hopefully that's better. But yeah. Right, and then for our last terminal, last but not least, this terminal is actually one of the, actually the most important one. So this actually determines what it'll provide the output for what level your potentiometer is at, or the dial of the potentiometer. So the wiper terminal, we're going to connect that to, we're going to be connecting that to, let's see here, I want to connect this. Here, this is very awkward, but we're going to be connecting this to contrast on the LCD. So the purpose of the wiper terminal, and even the potentiometer as a whole, is the potentiometer actually controls the brightness of the display. So typically, whenever you have an LCD, there's different brightnesses that you can set. So your potentiometer is the brightness setting, essentially. So you can dial it all the way to the right to set it at its brightest setting, or all the way to the left to essentially like turn it off, or get a very low brightness. So the wiper terminal will output a specific real value depending on what, I guess, angle your potentiometer is set to, and it'll put it into the contrast pin for the LCD and adjust the brightness. Okay, this is I don't know about y'all, but this the fact that it's not a 90-degree angle is kind of bothering me. I'm not OCD. I promise y'all, I'm not OCD. It's just I do like things to be aesthetic and very clean. So, but yeah. So there we go. We've got our potentiometer hooked up, and now all we have left to do is hook up the LCD. So the LCD, this can seem a little daunting. There's a 16-pin interface for the LCD. Each of these pins have different purposes. They're all labeled, so some of them you can tell that it's like pretty self-explanatory. You've got ground, which is typically denoted as GND. Ground, and then you've got VCC, which is power. So VCC is usually synonymous with 5V or 5 volt. VCC is usually just power. So these two are going to be your ground and power. You've got your contrast, which we already said is going to be connected to your potentiometer. You have your register select pin, read write pin, enable, and then you've got these 4 here that are called DB0 through DB3, and then another 4 that are actually it's 8 DB pins, essentially. So for today, we're just going to be using DB4 through DB7, but you can actually use any of these DB values. Essentially, they're all going to be used to display whatever you code into the LCD. But depending on which displays that you use, or depending on which pins that you use, you'll have to specify that in your code. So everything has to be consistent and line up. And so yeah, and then the last 2 are your LED anode and cathode, which are your ground and power. So these are a little bit different from the ground and power over here. We'll see later how we connect those. So we're going to go ahead and connect our ground to ground, as you guys, I'm sure you guys can guess. So we're going to connect that to our negative power bus strip right here, and we're going to change that color to black. So this kind of looks a little weird, but it's 2 wires both connecting to the same terminal. I guess we could also connect this over here, so it's cleaner. So yeah, and so ground to the ground power bus, and then power to power. That's self-explanatory again. So we'll change that to red as well. And now the next pin that we're going to be working on is the register select. So the register select is going to be a specific, it's essential for the LCD. So we're going to be connecting this to our Arduino outputs, digital output pins, the GPIO pins. So let's go ahead and put this onto the breadboard. We're going to connect this to, let's say, the strip number 7 on this side. And let's color this a different color. Let's make it like an orange. Yeah, let's make it orange. And then on the other side, we can go ahead and extend this all the way over here, and we're going to be connecting it to pin 12 today. Again, this is all the pins that you're going to be connecting, digital pins that you're going to be connecting to. These can all be manually set depending on how you want to arrange your wires. But you'll have to you'll have to be consistent with it in your code. But for today's purposes, you guys should probably follow along with me and connect it to 12 so that all of our code is, in the right spot, and I'll be able to easily answer questions about code or anything that's not matching up for y'all. So let's try to connect it to all the same pins today. So we'll keep this orange because it's denoting the same color of the same sort of output value. So I like to keep all the wires the same color for a specific output value. So orange in this case will be from pin 12. For read and write, we're going to be grounding this. So I'm going to ground this to black. Yeah, I honestly, it kind of puzzles me why read and write is grounded, but I'm honestly not too sure why read and write is grounded. But that's the way how it is in how to set up a basic LCD circuit. So if you guys know anything, if you guys who have worked with LCDs before, if you know why the read and write pin is grounded, then let us know in the chat and help teach all of us, actually. I'd like to know myself. So. All right, and then we have our enable pin next. Enable pin, we're going to do the same thing, almost the same thing that we've done with our register select wire or register select pin. Same thing, we're going to be connecting it to terminal strip number 9. I'll put it all the way over here. We're going to connect it to number 11, pin number 11 on the Arduino. And let's change this to yellow. All right, and then we're almost done now. We're going to be connecting 6 more of these pins. So we're going to be using DB4 through DB7. So DB4, we're going to do a similar thing with these pins. We're going to connect it to the breadboard in the respective. I'll do this so that it's all kind of. Oh, let me adjust this.
Alan, if you haven't, can you go over the orange wire again? The function of the orange wire?
The function of the, oh yeah. So register select, I mean, it's essential for, I guess, the output display for the LCD. Usually you have an enable, a register select. These two are what we're going to be using for output for the LCD display. So this will be connected to D12. Oh my goodness, extra wire. All right. Yeah. Any more questions? All right. Well, so these, so for DB4 through DB7, we're going to be changing these each to a different color. Make this turquoise, blue, purple, and pink. Nice. And then we'll just connect these two all the way over here And we're going to connect DB4 to pin number 5 on the Arduino. And we're going to keep that the same color, turquoise. So DB4 to pin number 5 on the Arduino, and we're going to connect DB5 to pin number 4. Change that to blue. Connect DB6 to pin number 3. And then DB7 to pin number 2. Yeah, so essentially the same order that they're the same order that they're in on the LCD display. We're connecting like in that same left to right order on the digital pins, 5, 4, 3, 2, 1, or 5, 4, 3, 2. And then for our last two, our LED anode and cathode, we're going to be connecting the anode to power, but this time we're going to be, instead of directly connecting it to the power bus, we're going to be connecting it to the resistor, which is over here. Remember the 220 ohm resistor that we set? And let's change this to like brown. And then cathode, we're going to be grounding that. So that'll be black. And that should be it, actually. So this is the completed circuit, completed wiring of our LCD display. And now that we're done with the circuiting and the wiring, we can start coding. Fun, my favorite part. So before we start coding, actually, I'll give a few minutes for any questions that you guys have. Coding is very simple, like literally like 6 lines or something. So once we get to, let's get everyone caught up to this part, done with the circuit wiring, and we can move on. Okay, so I think it was Micah. Micah, you were still asking about, you were still confused about the register select pin. So yeah, so just to clarify, or just to be like more specific, so the register select actually determines, if you want to get more into details, the register select goes into which mode that you want to set the input for the LCD. So there's 2 different modes. There's instruction mode and there's character mode. So essentially you control when you want to either move the cursor, clear the display. All these instructions would be done in instruction mode. Now the other mode that you would be putting it into is character mode, which is when you actually want to display characters or print output to the LCD. So there's 2 different modes. One, like, so you have like cursors, right? Imagine if you're on like Google Docs and you have a cursor, and the cursor determines where you're going to be inserting characters, right? or if you're like deleting something, removing characters, things like that. Those are all in instruction mode, essentially, in the LCD. For character mode, that's when you're actually printing output. So whenever you move your cursor in instruction mode to a specific location, and then you want to print a character at the location, that's when you switch from instruction to character mode. And yeah, that's essentially the purpose of the register select pin. Does that answer your question? All right, no problem. Yeah, if any of you guys have any more questions like that, feel free to ask. I will try my best to answer your questions. But yeah, so if we, I think we'll go ahead and start coding. I'll have the circuit still on right next to the code, so you guys can still kind of view it. But yeah, so we'll get into coding. So if you look at the coding, if you click the code on the top right section to toggle the code editor, you'll see there's different ways how to code. So you can use blocks, which is a very visually pleasing way to code. You can literally like click and drag different blocks in, and it's very simple to use. Yeah, you can have different output, input, variables. You can add math, a bunch of different blocks, right? Or you can do a blocks plus text. So this is like a combination of both. And I mean, whatever your preference is, depending on whether you prefer coding and looking at C code. If you guys didn't know, by the way, I should have mentioned this earlier. Arduino compiles C code and runs C code. So the programming language that we're going to be using today is C. And if you guys have no experience with C, totally fine. We'll go. The code today is very simple, very short and sweet. So there's not much you need to know for C to do this. But today, for the purposes of being technically, I guess, I don't know what the word is, being smart and looking cool with coding, we're gonna ditch the blocks. We're gonna go straight into just text, and we're gonna go into C coding. So you guys should definitely, if you guys are haven't yet, you guys should get familiar with coding, at least in C, because I know in C, C is really widely used for any kind of embedded programming, any kind of like microcontroller programming, except the Raspberry Pi. Raspberry Pi uses Python, which is a lot nicer to use in my opinion. I like Python more personally, but C is still very essential in a lot of places. So yeah. So for Arduino, you'll see that there's two functions. So these are the two basic functions. Let me see if I can. Sorry, I'm trying to like. I don't know if this is too small for you guys, but okay. All right. Well, I'm going to just zoom in, just so you guys can look at this better. But oh dear. Second. Yeah. Okay, Micah, you asked about C++ versus C. Yeah, so it's Star. So C and C++ are very similar. C++ is a more like advanced, or not advanced, but like it's a newer version than C. In that it's also easier to, it's like higher level in a sense. Syntax is a bit different. different like functionalities as well. C is very low level, and honestly, probably like the most like low level object oriented programming language that you can get these days. I might be wrong about that, but that's what I believe. So yeah, personally, like C++ versus C, dude, in my opinion, like I don't like either of them, just because it's just C. They're all C. I prefer like Java or Python. More cleaner, a lot like more readable, and yeah. So, but yeah, I think definitely C and C++. Yeah, they can usually be used interchangeably, um, except for very low level things. So yeah, just keep that in mind. So for Arduino, the basic code setup will have this function called setup. So this is going to be setting up all of your digital pins, your GPIO pins. So in our cases, these pins out here. And then also, if you have any analog pins connected, you'll be connecting those as well. And then we have so the setup will be essentially initializing all of those pins to whatever we've assigned them to. Now in our loop, this is essentially the main program that we're going to be running in our Arduino. So the loop, it does what it says it does. It loops over and over again and basically just continues running the code until you stop it. Or like, whether you unplug the power of the Arduino or you like actually write like type code that exits out of the program. But yeah, so this is the main sort of function that we're going to be using. So what we're going to be using today is the liquid crystal display library. So if you can go ahead and do this, so we're going to be including the liquid crystal display library, which the way how you do it is you type at the very top hashtag include and then liquid crystal.h in the I guess the less than and greater than signs. And this is standard syntax for including any sort of like header file or library in C or C++. And so this will essentially take all the liquid, like the LCD like functions and like everything that this library has and allow us to use it. All right, and then now so right before our setup, actually, we're going to be calling the liquid. So in the liquid crystal header file library, we have a constructor. Constructor is essentially, it just initializes the pins for our LCD. So LCD has its own built-in constructor that we can use. So we will be using that. So we don't actually have to initialize them ourselves in the setup function. So the way how we call the instructors, we call liquid crystal. Make sure the capitalization is the same as the header file. And then you can call it LCD. You can call it anything you want, really, but LCD is just very intuitive and easy to understand. And then, so this function, this constructor, will take in 6 arguments, so 6 values. I think that's 6. Whatever. We'll see if it's 6 later. But yeah, so these 6 values are going to be your register pin, whatever digital pin that you've connected your Arduino to for the register select pin. So in our case, we connected it to pin 12, so we'll put it there. And then our second value, our second argument, is the enable pin, and we've connected that, in our case, to pin 11. And then for the last 4 pin numbers, okay, so yeah, so we did have one extra. These 4 will be our 4 dB output ports, pins that were on the LCD. So these 4 were connected to, so these were DB4, DB5, 6, and 7. So we connected these to 5, 4, 3, and 2 on the Arduino. And I'll put this, make sure these are in. So register, select, enable. Oops, I just completely forgot. I've been coding in Python too much, but yeah. So the way how you put in comments in C is a double forward slash, and so once you double forward slash, you can comment out that entire line, and essentially you won't, the program won't read it as like code. So you can like use this to write like notes and stuff. Like for example here, this function waits for 1,000 milliseconds, so 1 second. But yeah, so this is essentially what the constructor is going to be doing. And these are the arguments that you're going to be passing into the constructor. So again, like I said, in our cases, we've chosen these specific pins on the Arduino, but you can actually choose any sort of pins to use. So we could use like 13 instead of 12. We could use like 10, or we could use like 1, 2, 3, 4, something like that. But we'll just have to be sure to be consistent. Whatever pin we've put our register select to, we have to use that specific pin number. But yeah, so in our setup, so all we have to do now in our setup, since we've already initialized our pins, is we're going to set up the LCD number of columns and rows. So the way how the LCD works is it's laid out in specific rows and columns. So we can take this out of the way. So it's laid out in specific rows and columns. So in this case, the way how you can kind of read this is we're beginning the LCD, essentially setting up the LCD sequence for 16 columns and 2 rows. So essentially, if you want to like look at this in perspective of the LCD display, you can kind of see the LCD display as you can split it up into 2 rows and 16 columns. Each column is essentially going to be the length of 1 character. So essentially, the LCD can each line of the LCD display, each row can display 16 characters at once, a maximum, and then the second row can also display 16 characters. And so that sets that up. I'm not sure. I think different LCDs you can specify like different like values for these. Honestly, I think you can specify different values for this specific LCD. Just depends on like what font, essentially, right? The more lines you put, the smaller the font will be. So yeah, and then we're going to go ahead and do a simple print statement. So in our print statement, the way how we print out something in our LCD is we're going to do lcd.print. Yeah, very basic, right? Super easy. And in here we put our double quotes, and we put whatever message that we want to print. So I'm going to say IEEE is awesome. All right, so now I want to make sure, okay, first I want to make sure this is less than 16 characters. So, okay, wow, we're lucky. This is exactly 16 characters. Okay, it works. So this should print out very nicely in our first row. So every single time that you put like lcd.begin or just set it up, your cursor, like I said before, from the register select value, it's set to instruction mode. So the instruction mode for the cursor, the instruction is to set it to 0, 0. So at the very first character. And so when we write an lcd.print statement here, that'll print this on the very first row. And it'll fill up the entire thing because this is 16 columns or 16 characters. Now, yeah, so essentially we can like take this out, take out the loop, and now if we press start simulation, oh yeah, wow, I've also still this Python, I've been coding too much in Python, but yeah, so C, C++, even Java, you need semicolons at the end of your statements. You're going to learn to love these semicolons. And by love, I mean really hate them, because sometimes you're going to forget about them and realize, oh my gosh, my entire code doesn't work just because of that one semicolon. But yeah, so semicolons are a must at the end of every single statement. Also this one too. All right. Okay. Interesting. Nothing is being displayed. Hold on a second. Let me check out. Interesting. Okay. Hold on, guys. Sorry about this. I am not sure. I must have messed up something here that I was not aware of. Does anyone see where I am going wrong here, for those of you who have experience with breadboards and Arduinos? Terminate resistor's top terminal is actually on 5 volts. I mean, yeah, the resistor is up here. Should automatically snap to it, so. Oh yeah. Okay, Micah. You are I completely forgot. This is okay. So Micah is correct. I completely forgot about this. So the reason why it's not on, or okay, so it's actually on, but the reason why we can't see it is because the potentiometer, which sets the value of the brightness of our LCD, is turned to 0. So once we turn it all the way, oh wow, look at that. Now we can see it. So yeah, thank you, Micah. That was a lifesaver. Okay. Yeah, I completely forgot about the LCD or the potentiometer. But yeah, so make sure y'all's potentiometer is rotated all the way to the right. So you can turn it just by literally just clicking it and like dragging it around, almost as if you're like, you know, turning it in real life, right? So you can see that. So it's not as subtle in TinkerCAD, but yeah, you have to start the simulation first in order for you to turn it. Otherwise, if you just stop the simulation, you're just moving it. But yeah, you have to start the simulation and then you can turn it. It's not very subtle, but once you get to the very end, it just snaps to like displayed. All right, cool, nice. All right, so now that's done. Let's turn this back to the original message because I like the original message better. There we go. Nice. So yeah, you can see you can tell the that the you can tell which rows there are and the 16 columns, right? Each of these like little grid boxes show where each character is going to go. But yeah, so then now in our loop function. So our loop function, like I said, prints out or runs every single time, like every single iteration. And this happens like as soon as the first iteration of the loop happens, the second one immediately starts. So there's no like really delay unless you specify yourself. So what we're going to do is we're actually going to do a print. We're going to print something very simple. We're just going to print timing. So it's like a specific, like basically count the number of seconds that it's running. So the way how we do this, so first, before we print that out, by the way, this would be LCD.print, but before we print this out, because originally our LCD cursor was set to the beginning at 0, 0, and we printed it, our cursor is still, you know, that's actually, I'm curious now. I'm not entirely sure if the cursor is now at the very end of the display or at the beginning of the display, or if it's still at 0, 0. I guess one way we can find out is if we do another LCD.print statement. Let's just type hello. So this is a interesting way how to figure out if this works. Okay, so yeah, so the reason why it doesn't print out is because the cursor is off the screen now, or it's at the very end, so you won't be able to print out hello for like anywhere beyond this point. So the cursor does end up, so the current cursor right now is set to the very end of this array, past the array, so you won't be able to print out anything else unless if you set the cursor to a specific value. So the way how we do this, I have to turn off the simulation, change the code. So the way how we do this is we do lcd.setCursor. And so the lcd.setCursor sets it to a specific row and a specific column. So in our case, it's actually the actual like order is lcd.setCursor column and row. It's really weird why it does column row versus row column, but that's just how the library is how the library was implemented. So I guess we can't really complain. But yeah, so the column in this case, if we want to write something on the second line at the very beginning, we're going to do column is 0 and the row is 1. So the reason why row is 1 is because if you've ever done any programming, you'll know that like arrays are indexed starting at 0, or counting is essentially starting at 0. And so when we're talking about the second row, we're actually talking about index 1 versus the first row, the index would be 0. So if we wanted to set this cursor back to 0, 0, we'd do 0, 0, right? So this set cursor sets it to the second row, first character. And then now we can do an lcd.print. So the way how we're going to do a print, we're going to print the time is, so there's a useful Arduino like function, built-in function called millis, which is milliseconds. It'll straight up just return the number of milliseconds that you have. And then we're going to divide this by 1000 to get the number of seconds. Don't forget the semicolons. And yeah, so this should go ahead and print out all of our, print out the number of seconds that this has been running as we wait. You can see here that the simulator time, it actually keeps track of how long your simulation has been running. So you can actually tell that every single time that the second reaches the second mark, it updates, right? And so yeah, so that's the basic. That's how you print to an LCD. Do a loop inside the LCD. You can also, I guess what's like really cool is you can stop this. You can also make it display different like things as well, I guess. Let's do, I'm actually interested, if we set the cursor to 0, 0 again, does it overwrite it? So if we set the cursor back to 0, 0 where we had IEEE is awesome, and then we print like hello. I'm curious to see if it, actually let's put this over here so that it doesn't like loop. Alright. Yeah, so it does overwrite it specifically. So it does overwrite the those values in those specific, like, so originally there was an I, E, E, E space, right? But now we've set the cursor back to 0, 0, and then we printed hello starting from that specific element, and so it just overwrites those values. So yeah, so that's essentially how it works. You can, based on these two basic like set cursor and print, and also using that in the loop, I'm sure you guys can do a lot of cool stuff with this. And yeah, basically you guys can play around, feel free to play around with it however you want, make some cool things. I personally think that you can also do like a, if you want to like, kind of like how the, so right now on the live stream, there should be like a banner at the bottom where it like prints out a series of like messages. So you can do that with the LCD as well. Imagine like the LCD is like the banner, and you can have it like print out a different message every single, like every set number of seconds essentially. You'll just have to have like an array of like different messages that you want to set, and then you'll basically just have to go through that array on each iteration of the loop. And yeah, that's how you would set it up. I won't set it up right now because this is the end of our workshop today. And so yeah, for those of you who came out and stayed the whole time, thanks so much for coming, and thanks so much for tuning in. I had a lot of fun, and I hope you guys did have a lot of fun as well. Yeah, actually, the website does say 4 to 6 p.m. I believe. We were actually aiming this to be done in an hour, but as you can see, we were 23 minutes late, technically. But yeah, because this was an introductory workshop, very basic. If you've never known Arduino, breadboards, or LCDs, this was a workshop for y'all. So yeah, I hope you guys learned some useful things, useful tools, especially TinkerCAD, right? And I hope you guys will use these in the future. And thanks for coming out and watching. So yeah, let's go back to the presentation. Yeah, thanks for joining. And if you guys have not yet signed in, so if you joined late or something, the sign-in link is here still. You can use the QR code to fill out the sign-in sheet if you did this at the beginning, you don't have to do it again. So yeah, thanks for coming out. If you have any like questions, comments, feel free to put in the chat. We're going to post this also. If you guys, I think some of y'all asked earlier if we're going to be posting this later on. Yeah, we're going to be posting the entire live stream as a video on our YouTube channel later. So if you guys want to refer back to it whenever, you guys will be able to do that. So check out our channel later on, and you'll be able to replay the video. So yeah, thanks for coming out. Join in, keep in touch. Make sure to stay tuned for more workshops. This is our first workshop in a workshop series. So the next workshop that we'll be doing will be a little more intermediate friendly. It'll require that you have basic knowledge of like programming, TinkerCAD, already all of these things that we've taught today. So if you did join, if you did watch this, follow along with this workshop, then you should know the basics that are required for the next workshop. So yeah, so definitely stay in the loop with our workshops, and hope to see you again. Thanks, everyone.
Did you end it? Are we done?